In our ongoing session for the theory of inorganic laboratory pharmacy 2, inorganic pharmacy 2 lab, today we are going to discuss about the theoretical part for the experiment number 03D, and the name of the experiment is qualitative analysis, that is identification of group 4 and group 5 cations. Now let's move on the principle. The principle states that salts are compounds which are formed from the reaction between acids and base. For example, ammonium chloride is a salt and that can be produced by the reaction between hydrochloric acid and ammonium hydroxide, where ammonium hydrochloric acid is an acid and ammonium hydroxide is a base. So we can say that salts are compounds which are formed from the reaction between acids and bases. An inorganic salt is just a salt which has no organic part in its molecular structure. In case of ammonium chloride, there is no molecular part in its molecular structure. There is no organic part in its molecular structure. Okay, in case of ammonium chloride, there are two parts: NH4 plus, which is a cation, and Cl minus, that is chloride minus, which is an anion. And we can say that the ammonium hydroxide gave the NH4 plus cation. That means the cation part came from the base, and hydrochloric acid provided the Cl minus anion, that is the chloride ion came from the hydrochloric acid. So we can say that the basic part came from the acid. So we can finally say that any salt is composed of two parts, that is cation and anion, and the cation part usually comes from the base and the anion part usually comes from the acid. Now, based on the solubility characteristics, the common inorganic cation, usually metal in nature, are classified into 5 groups. Cations of each group is precipitated by a common reagent. So, by stepwise addition of these reagents, we can first identify which group the cation belongs to, and then by using specific reagents, we can confirm the cation. The common inorganic cation can be classified into 5 groups based on the solubility characteristics, and cation of each class are precipitated by a specific reagent. Then let's look at the 5 groups of cation. The group 1 cation will be precipitated whenever we add dilute hydrochloric acid in the sample solution. Group 2 cation will be precipitated whenever we add hydrogen sulfide gas followed by addition of dilute hydrochloric acid in the sample solution. Group 3 cation will be precipitated whenever we add ammonium chloride in the presence of excess ammonium hydroxide followed by the addition of hydrochloric acid and then hydrogen sulfide gas. And group 4 cation will be precipitated by the addition of ammonium carbonate followed by the addition of dilute hydrochloric acid, then hydrogen sulfide gas, then ammonium chloride in the presence of excess ammonium hydroxide. And group 5 cation will not be precipitated by either of these 4 types of precipitating reagents. Okay, if let me state this again. We have to take a sample solution and then we have to add dilute hydrochloric acid in the sample solution. If addition of dilute hydrochloric acid produces any precipitation, then we can say that this sample contains group 1 cations, and we have to go for the confirmatory test for individual group cations that has been demonstrated in our lecture 3. Okay, now let us say what happens if the sample solution contains group 2 cations. If the sample solution contains group 2 cations, then we have to add dilute hydrochloric acid. It will produce no precipitate or PPT. Then we have to add hydrogen sulfide gas in the solution. Then addition of hydrogen sulfide gas will produce precipitate, indicating that this sample solution contains group 2 cations. And what happens in case of group 3 cations? We have to take the sample solution, then we have to add dilute hydrochloric acid. It will produce no precipitate if the cation is group 3 cation. Then we have to add hydrogen sulfide gas. It will also fail to produce any precipitate. Afterwards, we have to add ammonium chloride in the presence of excess ammonium hydroxide. This will produce precipitate. So then we have to go for the confirmatory test for the individual cations of group 3 cations. Okay, Now let's talk about the group for cations. Suppose we have a sample solution and we have added dilute hydrochloric acid, and the hydrochloric acid failed to produce any precipitate. Then we add hydrogen sulfide gas. This also produced no PPT. And then we add ammonium chloride in the presence of excess ammonium hydroxide. This also failed to produce any apparent precipitate. Finally, we add ammonium carbonate, and if ammonium carbonate produces any PPT, then we can say that the sample solution contains group 4 cations, and we have to go for the individual test to confirm which cation is present in this sample solution. And talking about the group 5 cations, if dilute hydrochloric acid, hydrogen sulfide gas, ammonium chloride, ammonium carbonate, ammonium hydroxide, everything fails to produce any precipitate, then we can say that this sample solution contains group 5 cations, and we have to go for the screening to know which cation is present, which group 5 cation is present in this solution. Okay, I think it is clear to you. As I was saying that cations of group 4 are not precipitated by dilute hydrochloric acid, hydrogen sulfide, as well as by the addition of ammonium chloride in the presence of excess ammonium hydroxide. If no precipitate is formed with the addition of ammonium hydroxide and ammonium chloride to the stock solution, then ammonium carbonate is added to it. If precipitate is formed, then group 5 cations are present. When ammonium carbonate is added to a salt solution containing ammonium chloride, ammonium hydroxide, the carbonate of barium, calcium, and strontium are precipitated. Let us say if calcium is present in the sample solution and we have added ammonium carbonate in the solution, then calcium will react with the ammonium carbonate and will produce a white PPT of calcium carbonate, indicating that this solution contains group 4 cations. Now let's take a look how the group 4 cation, the group test is performed to identify the cation present in this sample solution belongs to the group 4. Let's take a look the group test for group 4 cations. We're going to test for the presence of group 4 cations. We are taking the sample solution in the test tube. Into this sample solution, we would add 6 molar dilute hydrochloric acid. If PPT appears, then it would be an indicative for the presence of group 1 cation. If PPT do not appear, then it may be group 2, 3, 4 or 5. There is no PPT. There is no PPT. Indicates that there is no group 1 cation. Now we are going to apply hydrogen sulfide gas into this test tube. Now we are applying hydrogen sulfide gas into this test tube, which is containing the hydrochloric acid and the sample solution. We are trying to add or apply a huge amount of hydrogen sulfide gas so that our later process becomes very easy. I think we have provided enough amount of hydrogen sulfide gas. Now enough. That's all. The upper opening of the test tube should be covered with the hand so that the gas doesn't escapes from the test tube. Now into this PPT, into this test tube, we are going to add 9m ammonium hydroxide, concentrated ammonium hydroxide solution. If PPT appears, then it would be an indicative of the presence of group 3 cations. There is no PPT, so group 3 cation is absent from this sample solution. Now we are going to add ammonium carbonate solution. If PPT appears, then it would be an indicative of the presence of group 4 cations. Ammonium carbonate, we are going to add ammonium carbonate. Ammonium carbonate. There is a appearance of PPT indicative that the presence of group 4 cations. This indicates that this sample contains group 4 cations. That's all for the test for presence of group 4 cations. Hope you have understood how the group 4 cations are treated or tested or identified in the sample solution, provided that we didn't use ammonium chloride because ammonium chloride was needed to potentiate the reaction. Without the ammonium chloride, only concentrated ammonium hydroxide was enough for us to detect whether it is group 3 or group 4. That is why we didn't use ammonium chloride. Okay, now let's move on the individual test for group 4 cations. Okay, when ammonium carbonate is added to a salt solution containing ammonium chloride and ammonium hydroxide, the carbonate of uh, calcium is precipitated. We are talking about the confirmatory test for calcium 2 plus ion. So we have already stated that when ammonium carbonate is added to a solution containing calcium, then the calcium will react with the ammonium carbonate and will produce a white PPT of calcium carbonate, indicating that the presence of calcium. Then afterwards, in this PPT containing test tube, we have to add glacial acetic acid or hot acetic acid. If we add glacial acetic acid or hot acetic acid in the test tube that contains the PPT of calcium carbonate, then the PPT will dissolve by reacting with the acetic acid, because the reaction of acetic acid with calcium will produce a soluble complex. Calcium acetate. This is a soluble complex. This is the confirmatory test for the presence of calcium ion in the sample solution. Okay, let me state this again. We have to take the sample solution, and in the sample solution we have to add ammonium carbonate. Addition of ammonium carbonate will produce a white PPT of calcium carbonate. Then this calcium carbonate containing test tube, we are going to add glacial acetic acid or hot acetic acid. Addition of glacial acetic acid will solubilize the PPT, because glacial acetic acid or acetic acid will react with the calcium carbonate and will produce what calcium acetate, which is a soluble complex. Okay, now let's take a look how does the confirmation for the presence of calcium ion is performed in the lab. For the presence of calcium cation, we are taking the sample solution in the test tube. Into this test tube, we are adding ammonium carbonate. This ammonium carbonate will produce white PPT. This will produce white PPT. This is a white PPT. This is an indicative of the presence of calcium cation. Calcium has formed calcium carbonate and appeared as a PPT. This is all about the test of calcium. Into this PPT containing test tube, if glacial acetic acid is added, then this PPT will disappear, will form a solubilized solution. Now we are adding 100% pure glacial acetic acid into this PPT, and this will be solubilized. The PPT is dissolving. PPT is almost completely dissolved. This is all about calcium, and this indicates the presence of calcium cation. Hope you have understood how the calcium is detected in the laboratory. Now let's move on our another cation which belongs to group 5 cations. Calcium is another test we didn't perform in the lab. Calcium can also be detected by the flame test. In the flame test, the calcium will produce a briquetted flame, and the briquetted flame is produced by dripping the platinum wire into hydrochloric acid, then dipping the platinum wire in a sample solution containing calcium, and heating this platinum wire coated with calcium will produce a briquetted flame, and that confirms the presence of calcium. Okay, this is a dry test. Now let's talk about group 5 cation, ammonium. Ammonium is a group 5 cation, and if a sample solution that contains ammonium will produce no PPT by the addition of hydrochloric acid then followed by hydrogen sulfide, then ammonium hydroxide, then ammonium carbonate. After adding all the precipitating reagents, if no PPT appears, then we can say that this solution might contain group 5 cations, and we are talking about ammonium as a representative of group 5 cations. So how does the ammonium is confirmed in the sample solution? To confirm the presence of ammonium, Nessler reagent is added to a solution containing ammonium, and Nessler reagent produces a brown or yellow precipitate. That confirms the presence of ammonium in the sample solution. Another test when a sample solution that contains ammonium is heated, then a colorless gas produces, and the gas contains a characteristic ammoniacal smell. And this gas that produced by heating the sample solution containing ammonia will turn a moistened red litmus paper into blue. That means we have to take a sample solution in a test tube and we have to heat the sample solution. After heating, it will produce a gas. The gas will have characteristic ammoniacal smell, and the gas will turn the red litmus paper into blue. Okay. And finally, we can test the presence of ammonia by heating the ammonium solution and placing a moistened rod which has been moistened with hydrochloric acid at the upper surface of the test tube where the gas is evolving. The gas so produced will react with the hydrochloric acid and will form ammonium chloride, and the ammonium chloride will appear as a white film. Okay, that means we have to take a sample solution. We have to burn we have to heat the sample solution. Let us say we have taken a sample solution in a test tube. We are heating the sample solution in the test tube, and after heating, the sample solution will produce moisture, or produce we will be boiling, will boil and will produce some evaporating gas. The evaporation of the sample solution, if the evaporation of the sample solution comes in contact with a glass rod that is moistened with hydrochloric acid, then hydrochloric acid will react with the evaporated gas and will form ammonium chloride. That means the evaporation of the ammonium containing solution will produce ammonia. The ammonia will react with hydrochloric acid and this will produce white film. Okay, let me clarify these things again. The first test indicates Nessler reagent. We have to take a sample solution in a test tube and we have to add a Nessler reagent in the test tube. If a yellow or brown PPT appears, then we can say that this solution contains ammonia. Then in another test tube, we have to take another sample solution and we have to heat the sample solution. Heating the sample solution will produce ammonia, NH3. This ammonia has a characteristic odor which is known as ammoniacal smell, and if we place a moistened red litmus paper in the evolving path of ammonia, the red litmus paper will turn into blue, indicating that this solution contains ammonia. Another test, we have to take another sample solution in another test tube. We have to heat the test tube. Heating the test tube will produce a colorless gas. The gas is basically NH3, that is ammonia. If we place a glass rod moistened with hydrochloric acid, then this hydrochloric acid will react with the produced ammonia and will form ammonium chloride. Ammonium chloride appears as a white film, indicating that the presence of ammonium in the sample solution. Now let's take a look how does the presence of ammonia is detected in the test in the sample solution by laboratory method. We are going to test for the ammonium cation. This is a group 5 cation. At first, sample solution is being taken in the test tube. Into this sample solution, we are going to add Nessler reagent. This Nessler reagent will cause brown precipitation, which is an indicative of the presence of ammonium plus ion. Brown precipitation. There is a brown PPT at the end of the test tube and this is an indicative of the presence of ammonium cation. I told you that the PPT will be brown or yellow. This is basically yellowish in color. This may be brown, this may be yellow. It can be regarded as brownish yellow. Okay. We are taking another 2 ml sample for another test of NH4 plus, that means ammonium solution. Into this solution we are going to add 3 ml sodium hydroxide solution. This is sodium hydroxide solution, concentrated sodium hydroxide solution, into this test tube. After this addition, we will heat the test tube. We will heat this test tube. We are heating the test tube. When the gas evolves, this gas will turn red litmus paper into blue. After heating, when the gas evolves, it has a ammoniacal smell, and it will turn red litmus paper into blue. The red litmus paper will become blue. And the red litmus paper has become blue in color. The red litmus paper is becoming from red into blue. It is blue. And whenever hydrochloric acid dipped glass fruit is placed at the mouth of the test tube, it is producing white fume. This is all about ammonium. This white fume indicates the presence of ammonium. This is the white fume of ammonium chloride. We are going to test. Hope you have understood how the group 5 cations are tested and tested in the laboratory and identified the individual groups. Thanks to all for watching.